you guys were doing is you had the angle of B and the side of B opposite it. So what I asked that you guys did yesterday when you found that, I asked that you guys circle it. Okay? So hopefully you started by doing this. All right? From that, you knew that you were going to use the angle B and the side opposite, little side B, to solve for the other parts that are missing. Well, the only other part that you're given right now is side A, which means it's forcing you to find angle A. Okay? So what we do is we write it out to find that first. We have the sine of the 86 is to its side opposite of 20, as the sine of angle A is to 10. When you're finding an angle, because we don't know the angle, this is where you have to use your inverse button. We're going to have to use the second sign to figure out the angle. All right? So you set it up. The only thing you have to worry about here is moving the, we care about updates. The only thing you have to worry about is moving the 10, which means how do you undo divide by 10? So you rewrite 10 times the sine of 86 over 20 is the sine of A. Yesterday when we talked about this, all that stuff with the fraction, it's just some crummy decimal. We need to figure out that crummy decimal. So we type it in. Fraction bar, 10 sine 86 over 20, and we hit enter. That decimal equals the sine of an angle. What we need to do now is find the angles. This is where you hit your second sine, second answer. You hit enter. That gives you your angle, 2992. Okay? So that means your angle A is 2992. You fill it in. How many degrees are in a triangle? 180. You've got 2 out of 3 angles. What do you do to find the third? Yes, you subtract and back them out. Okay? When you do that, I think, I forgot what we got last time. Thank you. 6408 for angle C. So now I do the same thing using the law of sines, but now I'm not finding an angle. Now I have to use it to find a sine. So we do the same setup. Sine 86, because that's what we know to start, is to 20. As the sine of 64.08 is to little c. Whenever you found the side length, again, the scenario for which we set them up to solve them was always the same. Exchange-o, change-o with the c, multiply by the denominator. So you'd get little c is 20 times the sine 64.08 over sine of 86. Again, we would have to press some buttons. Fraction bar, 20 sine 64.08 over sine 86. Always write down what you're going to put in the calculator before you do it. I had 1803 for that other side one. And like I said yesterday, when we did this stuff, there's really no reference for us to know if we're correct, except for the fact that we know that the biggest angle is opposite the largest side length. And if that pattern holds true, where you've got the smallest angle, the shortest, the medium, and so on, you're probably on the right track. Okay? So our largest angle was the 86. The 20 is the biggest angle, or excuse me, 20 is the biggest side length. The next biggest is the 64.08, the 18, and so on. So in theory, it's close-ish. Okay? Now, what people are doing is sometimes that I've been finding is instead of letting the calculator do all of the work, they're rounding things out before they do inverse sine functions. Don't do that. Just let the calculator do the work for you. Don't write down 2 decimal places and then type it in the calculator. Let the calculator do all the work. Okay? That's why we just keep writing it out and going from there. Okay? Does that help out on 4? What else did you want to look at? 3? In 3, you're starting out with 2 angles and a side. You've got the angle side angle scenario. So this one is forcing you to find the missing angle first. How many degrees are in a triangle? Back out the 96 and back out the 32. What do you? I'm not sorry, 94 and the 32. What are you left with? 64? 54. Okay. Do you now have an angle on its side opposite? Yeah. So now you use this guy to make it work. Right. Sine 54 to 26 as the sine 94 is 2 little a. Sine of 54 is 226 as the sine of 32 is 2 little c. Both of these guys are the ones you have to find in the side length, so you're going to do the same algebra, same maneuvering of the fractions to make it work. Exchange O, change O, multiply by a denominator. Same thing down below. Exchange O, change O, multiply by the denominator. Excuse me. And then we go back and type it all in. Okay. Fraction bar 26 sine 94 over sine 54. 3206. And 1703 for those two sides. You've got 2 angles. It's always the nicest one because all you have to do is subtract it out. As long as you subtract from 180, you'll be okay. All right, you go from there. Now, one of the things that I have seen, that I see, not just with you guys, I see with my honors kids as well when they do this stuff, is that they'll write everything out. When they get to here, they might actually bump the wrong number. It is so unbelievably important to write down what you're about to put in the calculator before you do it. Okay? Yesterday I was grading a bunch of their quizzes, last night I was grading a bunch of their quizzes, and we're doing kind of the same stuff, albeit they're a little more complicated. But by them giving me, they wrote out the correct way of doing something, they gave me a wrong answer. I'm able to work backwards to figure out what they typed, because I kind of know what numbers got changed. And it's really easy, instead of doing 17, to type in 18. Or flip-flop a 23 and a 32. You know, that happens all the time. So just be careful, because there's no realm that you would make any sense of these crummy-looking decimals that make any relevance to you at all. So that's why I just want to make sure you guys write it out so it's easier to figure out what went wrong. Okay? All right. So today what I want to do is I want to talk about what happens when law of sines doesn't work. Okay. Law of sines doesn't work, so we're going to use what's called law of cosines. For example, you're going to want to write this down because this is the one that gets really messy. Excuse me. So you have what's called law of cosines. And we are going to use this if you have what's called side angle side, or when we have side, side, side. Remember, side angle side is when you have an angle in between. Side, side, side is when you just have the 3 sides. Again, this is still triangle, still 3 sides, 3 angles. Okay? What happens with law of cosines is that it's always dependent upon what information you have. Remember how we always label? We're always going to deal with the big angle is opposite the small side, small letter, and so on and so on. That pattern still holds true. You guys ever heard of the term literal equation? Let me ask you this. Do you know what this stands for? You've all seen it before. No. Distance equals rate times time. If I wanted to get rate by itself, what would you do? Divide by time, right? You just manipulate the equation to change it around. Okay. What happens with law of cosines is that there's 3 different versions of it, depending upon what information you're working with. Okay. So, depending upon what angle you have or what side you're trying to find, you use specific things. So I'm going to write out the 3 before I kind of explain to you why there are of them. So, first one is this. B squared plus C squared minus 2BC cosine A. Look for the pattern. See if you can pick out the pattern of what I'm doing. Remember, I'm not going to make you memorize any of these. I'll always give them to you. You just have to know how to use them.
We're trying to find cosine C and multiply 2 times A and B times cosine.
Well, notice that when I say the word tails, I'm looking at the ends. You see how there's an A on one side and an A on the other? There's a B, a little b and a big B, a little c and a big C, little a and a big A. What happens is, law of cosines, depending upon what information you're given, you're working with specific value. Okay? In this case that we have here, when I'm looking at the example I have on the board, we have, again, triangle ABC, little c, little a, little b. Notice how we have an angle, but we do not have the side opposite. Law of cosines will let us find that. Okay? The law of cosines lets us find that. Because once you have an angle on the side opposite, you would automatically use sines, because that one's really easy to use after a while. Remember, we have that that's been using. Okay? What angle do I know in our example here on the board? Angle B. Since I know angle B, and this is side, angle, side, see how that works? That's what I meant by that. I'm going to use it in terms of B. I would have my B squared and my cosine of B at the end.
Is that 45?
It is 45. 45, 88, 43. So the first thing I will always do is identify what parts I'm trying to solve for, which angle do I know, or what side am I trying to find, and I write out that form of the equation. What's little a? What's little c? And big B? 88. I know all of the information to put in on the right side of the equation. I write it down. B squared is 45 squared plus 43 squared minus 2 times 45 times 43. Notice I'm putting them in parentheses just because the grouping makes it work that way. And then the cosine of 88. Where's my variable, on the left or the right? Yes is the right answer, but where is it? Where's the variable that we're trying to solve for? Is it already by itself? Except for the squared part, right? Well, when you're trying to find a side like this, that means I'm literally typing all of that other stuff in the calculator the way it's written. This is just going to give me some number. So I take my calculator out, and I type it in. And I want you guys to get in the habit of, when you're finding a side length, type it exactly the way you write it down, with the parentheses and everything. 45 squared plus 43 squared minus 2 45, 43. Cosine, make sure you hit the cosine button. Okay? It doesn't all fit in the screen at one shot, but then you hit enter. It gives you some crummy decimal. Bless you. That crummy decimal equals b squared. What do I do with that crummy decimal now? Square root it. Very good. Again, this is already stored in the calculator. No reason to rewrite it out. Just square root of your answer. There's your b value. Second square root, second answer. So little b, 61.15. Do you now have an angle and a side opposite? Okay. Once you have that, you circle it and you go back to law of sines. It's a lot of stuff, but it's really easy. It's really fast. You just type it in and press a button. All right? That's what's nice about law of cosines. For this style, for side angle side, it's really easy to set it up. Because now to finish out the problem, all right, with law of cosines, there's going to be one little small rule that I want you guys to follow. When it's side angle side, and you're trying to find the side first, the next angle you find, I want it to be the next largest angle. Okay? What's going to be the bigger angle? Angle A or angle C? A. Always find the next biggest angle as you're working your way through law of cosines. There's subtle reasoning for that you'll learn about in Algebra 2, but if you just remember in your head to always start with the biggest angle and work your way down, you're going to be okay. All right? So then I would figure out law of sines to find angle A. So sine, was it 88, is to 61.15. Sine of A was to 45. And now this looks exactly like what you did yesterday. If we got to get the A value, the sine, we have to just move the 45 up, like we did yesterday. And again, we're going to type this all in the calculator, and now we have the inverse sine to get the angle. Fraction bar, 45, sine 88 over 61.15. And now second sine, second answer. 47.35. How many degrees are in a triangle? You know two of them. What do you do to find the third? Yep. 44.65. And then lastly, I would just check and see big angle, large side, small side, and see if it works itself out. And I believe it does so again here. Okay. There's a lot of buttons here, guys. There's a lot of buttons. That's the tricky part. And it's just a matter of filling them in correctly. Okay? As long as you're comfortable pressing buttons, you're going to be just fine with this, especially as we start this stuff up. Okay? Let's try another one like this real quick. I got this. Okay. Same idea. I have triangle ABC again. This time I'm given angle C. I have side A at 9, side B at 4. I do not know side C. This is another example of what we call the side angle side, where in fact I'm trying to find the side opposite my given angle. Okay. What letter is my given angle? C's. Okay. So of the three different versions of the law of cosines, which they're all the same, just different lettering, which one am I going to write down? The ones with C's on the tails. Okay. I write out that. Little c squared is a squared minus 2ab cosine of big C. We have all of the information for everything on the right side of the equation. We just need to fill in the blanks. C squared is 9 squared, so 4 squared, minus 2, there's 9, there's 4, there's the cosine, 128. Oh, sorry, I just realized I hit the wrong button there. There you go. 128 for the cos. So right now I have c squared equals 121 and change. What do I have? Not 121, sorry, 121. What do I do with that 121 and change then? Square root it. Yep. Square root is the answer, yeah. Did you figure that out now, okay?
Yeah.
Square root, answer. I got, when I round that to 2 decimals, I'm going to get 11.89. Am I right back? Oh, yes, ma'am. Do you now have a side and an angle opposite each other? So you circle it, and which of the two angles you're going to find next? Angle A or angle B? A. Always go with the next biggest angle. Always work that way. Alright. So you just lost signs again. Sine 128 is 11.89. Sine of angle A is 2. 9. Fraction bar, 9 sine 128 over 11.89. Curly decimal equals the sine of an angle. Second sine, second answer. What's that? Are you at curly decimal of 0.5 and change?
Yeah.
It's second sine, second answer. Just like we did yesterday when we tried to find angles. That's what I got. 3662. Yep. Now how many degrees are in a triangle? 180. And you know 2 of them. What do you do? There you go. I'm betting that the decimal is 0.38, but the rest of it I'm not sure. Yes, sir. There you go. Is the biggest angle across from the longest side length? Yes. Smallest angle across from the shortest side length? Yes. That's really all we're going to be able to do to verify that you're on the right track. That's only one version. There's another one. We just did side, angle, side, which I think is the easier one. Side, 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 it's not any more difficult. You just have to break the equations into smaller chunks. I'm sure what I'm talking about. Side, side, side means that you know all 3 of your sides. Like this. Triangle ABC. Little a is 4, little b is 6, little c is 5. I don't know an angle, okay? Which means my rule is going to be, if I have side, 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 my rule will always be find the largest one first. Which of those 3 angles is going to be the biggest? B. Okay? That's the little, just like I was saying earlier, find the next largest and all that. With law of cosines, especially the side, 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 always find largest angle, first. Okay? And then you'll work your way down. Alright? So my largest angle here has to be angle B because the longest side length is across from it. So I'm going to write out the equation in terms of B first. B squared is A squared, C squared minus 2AC cosine of B. We're trying to find big B. So that means we know everything else but that. So fill in everything else. Little b is 6, so I'll write 6 squared. Little a is 4, 4 squared, 5 squared, minus 82 times 4 times 5 times the cosine of b. At this point, this problem really isn't anything different than that. What would you do first if I had to solve for x? I would subtract the 4, good. And then I'd have 8 equals negative 5x. Then what would you do? Divide by negative 5. And then you'd get some crummy decimal where you'd leave it as a fraction, right? All right. Now, there's nowhere here, I can't write that as negative 1x, can I? No, they're not the same. Okay. Same idea here. What's happening here, what I want us to get in the habit of doing is, let me just erase these movements. What's happening here is that there's 1, 2, 3 parts I want us to simplify. What's 6 squared? 36. All right, 36 equals. What's 4 squared plus 5 squared? 41. 2 times 4 times 5. Yeah, that's why I just wrote down the minus. This will always be minus whatever that is. That minus sign always stays there. It's going to be 40. Are we okay with that? And this is times the cosine b. Okay. I need to start moving things away from the cosine of b. What do you move first? Yes, ma'am. How do you move it? Perfect. Absolutely. Write it down. Subtract 41. You're exactly right. Subtract it, you get negative 5. Now, what's left on the right-hand side is still the minus 40 cosine b, so I write it down. Negative 40 cosine b. That stands for negative 40 times the cosine of b. How do you want to do it? Divide. How do you undo multiply? Divide. Divide by negative 40. Now, at this point, this is going to give you decimal in it. Okay? Let's do our calculator. Negative 5 divided by negative 40 gives me 0.125. That equals the cosine of an angle. How do you find the angle? How do we always find an angle? Inverse. It's not sine now, it's cosine this time. Because we're using cosine. Inverse cosine of your answer. There's your angle. 82.82. Okay. Remember, it just gives you a crummy decimal. So that gives us our angle at 82.82 after you do your inverses. In your diagram, do you now have an angle on the side opposite? So what are you going to use that? You go back to the law of sines. You only ever use cosine once. You only use it once, then you go back to sines. So now, what angle am I going to find next? A or C? Yep. C. Always go in order. C is the next largest. So sine 82 over 6. Sine of C over, what was that, 5? Then we'll have to do another inverse. Okay. Go back to your pen. You're going to make it all right, man? Yeah. All right. Again, go press the buttons. Throw it in the calculator. Oops. Move it. So fraction bar. 5 sine 82.82 over 6. Crummy decimal is now the sine of an angle. So we got to pay attention. Are you using sine or cosine? Okay. Go back to your buttons. Second, sign. Second, answer. And I got for angle C, 55.77. Like, convenient. Do we now have two angles out of a triangle? Yep. What do you do to find a third? And what'd you get?
41.
41, 41? That's how it works. Cosine, when you're trying to find you have to find that other angle. It's just a little weird because you have to break it into smaller chunks. Otherwise, too many people make dumb mistakes. What's up?
What happens if you like didn't go on
It has the possibility to do so. There's some very subtle rules that happen as you get to algebra 2 and pure calculus and so on and so on. What'll happen is certain angles, put your pencils down real fast. Certain angles, if I'm in the first quadrant, your x and your y values, they're both positive. You guys okay with that? If you move to the second quadrant, your x value is negative and your y value is positive. You okay with that? So if you have your calculator out real quick, type in, let's say this is 30 degrees. If I'm up 30 degrees from 0, and if I'm up 30 degrees from 180, if this is up 30 degrees from 180, what is this whole angle going to be? What's 180 minus 30? Really? 150. So that's 150. So what I want you to do real quick is I want you to type in the cosine and then the sine of 30, and do the cosine and the sine of 150. If I do the cosine of 30, it gives me root 3 over 2. The sine of 30 gives me 1/2. So root 3 over 2, 1/2. If I do the same thing with 150, cosine 150, it gives me negative root 3 over 2. Sine 150 is still 1/2. What happens in algebra 2, angles can be placed in it's what's called standard position. If they're placed here, and this angle and this angle have the same, what's called reference angle, how far are they off of the axis, if that's the same, their ordered pairs are the same, except the signs, SIGN, changes. Okay? That's why the x value went to negative because it switched to the second quadrant. The y value stayed positive because they were parallel, or they're horizontal to one another. What happens in algebra 2 is that when you have acute and obtuse angles, it's possible for their sine values to be the same. That's why the sine of 30 and the sine of 150 they're both 1/2. What happens later on is that if you have an acute angle, there can be a matching obtuse angle that you can create multiple triangles with the same side lengths. By using in order of largest to smallest angles, you avoid the possibility of what we call the ambiguous case of the law of sines. That's why we're just trying to, whenever you use cosines, if you go in order, you're less likely to run into that. It's not completely possible that you won't run into it, but it's kind of why we do it that way. So to answer your question the long way, when this happens, it's annoying because there's a lot more work. You just have to find multiple triangles. I'm just prepping you guys to get in the habit of finding biggest to smallest, and you'll be, when you get to this, you'll be like, oh, that's why Murphy said that. He's not just a complete total lunatic. Thank you. All right. Let's do another one like that. 17, 11, and 9. A, B, C, 11, 17, 19. Little a, little b, little c. Same idea. Excuse me. Which one is this making us find first? Good. It's making us find the c value first. So write it out. Write out the formula in terms of c's. So our little c squared is a squared b squared minus 2ab cosine c. Fill in the blanks. Guys, you're gonna want to write this down. 11 squared, 17 squared. Okay. When you get to this part, underline the parts that you have to separate. Don't combine them. The only ones you combine are the two you're adding together. Okay. Simplify them out. So we had what, 19 squared? 361, thank you. 11 squared plus 17 squared is? 410, thank you. Minus, well, 2, 11, and 17 is, not and, I mean multiply, excuse me. Negative 374 cosine of C. Everybody with me on that? All we did is we broke down the small chunks. I have to move the 410 first. Again, how do I move that 410? Subtract. Good. Show it. Minus 410. You get, what is it, negative 49? Okay. So negative 49 is negative 374 cosine of C, which means what do you have to divide by now? Yep. So this value here is going to give me my crummy decimal. I type that in. 49 over 374. I took out the negatives because it was going to have to be positive and negative divided by negative. It's going to be okay. I get crummy decimal. To find the angle now, second cosine, second answer, because I'm using cosine. Oh, what did I hit? Oh, I hit enter? Oh, I hit negative. I must have, yep. Try that again. There we go. 82.47. Okay. There's your angle for C. You now have an angle on the side opposite. Yep, circle it, just like we did yesterday. Now you do law of sines. And we're going to find angle B next. Which means all we have to do is move the 17 over. So we'll have fraction bar, 17 sine 82.47. Oh, forgot to put over fraction bar, sorry. Over 19. This crummy decimal equals the sine of B. So again, to find B, second sine, second answer. $62.5. Do you have 2 out of the 3 angles? Yep. Subtract them out to get the third. 44, 49, so do what? 3503. It's kind of messy, but it's not that bad. If you break it into smaller chunks, it shouldn't be so bad. All right. It don't take that long. We'll just learn.
Yeah, maybe myself. Why are you laughing? I'm serious, man.
This one here, I realized that after I made the copies and labeled everything out, I had to, no, I fixed all the lettering, but what I didn't do is I didn't give you one like this last 2 examples we did. So what I want you to do is cross off number 4, but on the back, I want you to do this one. Just still going to do 4 of them. But on the back, just cross off number 4. Okay? Draw an arrow and remind yourself. Okay? So we'll just do that one instead of number 4, because all the other ones, you're finding the angle, or excuse me, you're finding the side length real fast. That's the one that's the setup that's really quick. You're finding the a squared or the b squared or the c squared. You're finding that value first, and then you can jump right to the law signs. This is the style where, which angle do you have to find first in this example? Yeah. What angle would you find first here? Huh?
C.
A.
A.
Yeah, you'd find A. So right away, you know you'd have to use the A value for this one. You'd have to write out a squared, b squared, c squared minus 2bc cosine, and so on. Right? And then you would figure it out from there. All right. There's just the 4 of them. Shouldn't be so bad. Tomorrow what we'll do is we'll take these things and put them into like an application style where, you know how we did elevation and depression? We kind of can do the same style of a problem. Aside from, with elevation and depression, there's always right triangles. Here, they're not going to be. Here it's going to be, well, I can say that 2 ships are 200 miles apart. The angle from one ship to the lighthouse is 17 degrees. The angle from the other ship to the lighthouse is 23 degrees. How far is one ship from the lighthouse? You can do stuff like that. Not so many words. Oh, but that was a depression one. That was a it was a double angle depression where you find the far, find the close, and subtract it. Yeah. That's how it works. Yes, sir. The small letters always go opposite the big letter. So angle A opens up to little a. Does that make sense? Yep. Angle A opens the big A, little B, angle B, and so on and so on. Yes, ma'am. Probably have to do it tomorrow. I get behind and just life happens. Okay. We'll get there. Makeup work is always tough to get caught up on.